Okay, this lesson is about locating relative extrema. At the end of this lesson, you should be able to associate the derivative in locating what we call stationary points, critical points, or points of inflection. Let us consider having this curve for the function y equal to 1/2 of x to the fourth minus 4x cubed minus x squared plus 4x plus 1. If we are going to trace the curve going from left to right in the direction of positive x, over here we go downhill, indicating that the function is decreasing and that y prime values at this particular section would be with negative values. At this point, the tangent line would be horizontal and therefore y prime would be 0. But on its right, we observe that we go uphill tracing the curve, therefore y prime values would be positive. But again, over here, y prime would be 0 because the tangent line would be horizontal. But in this section, going downhill, y prime would be negative, and then 0 again, and then positive. Okay, so we observe that there are points on the curve where y prime would be positive, negative, or 0. Now observe that at this point where y prime is 0, this point is lowest compared to its neighbor points. But over here, where y prime is again observed 0, the point is highest compared to its neighbor points. But here again, y prime is 0 and that the point is lowest compared to its neighbors. So that at points where y prime is 0, either we observe the point to be lowest or to be highest. And observe that in this particular graph, this point here, okay, which is observed at x equal to -1, is lowest overall. Compared to all the points in the curve, this is the lowest point on the curve. But this other point here is just lowest compared to its neighbor and not overall. Now observe also that this point here is highest but compare only to its neighbor and not overall. So a point can be lowest point overall, and that would be referred to as an absolute or global minimum point, and that is observed at x equal to -1 here, or it can just be a local or a relative minimum, meaning it is just lowest compared to its neighbor but not overall, and that is observed at x equal to 2. And that a point is highest, either compare only to its neighbor or overall. And in this case, this point is highest compared only to its neighbor points, and therefore it is referred to as a relative or local maximum. Okay, let us now try to work out a more general observation. Consider having the graph of the function y equal to f of x as given by the yellow curve, and take note that there are points on the curve where the tangent lines are horizontal and therefore y prime is 0. These are observed at x sub 1, at x sub 2, and at x sub 5. Now please take note also that at points where y prime is 0, the point can either be highest as compared to its neighbor and therefore is referred to as a maximum point, or is lowest as compared to its neighbor points, referred to as a minimum point. So a maximum point or a minimum point on the curve would be points where y prime would be equal to 0, and that a maximum point or a minimum point can either be a global or a local maximum or minimum point. However, please take note that there are points on the curve which are observed also to be highest compared to its neighbor, as in x sub 3, or lowest as compared to its neighbor as given in x sub 4. But take note also that the tangent line at points defined at x sub 3 and at x sub 4 cannot be drawn or are not defined. Okay, so if the tangent line to the curve cannot be drawn at points, then we say these points are points of non-differentiability of the function, but can be maximum or minimum. So at this point, we generalize that the points x1, x2, x3, x4, x sub 5 are critical points. These are points where either y prime is 0 or y prime is undefined, and that x sub 1, x sub 2, and x sub 5 are called stationary points. These are points where y prime or f prime of x is equal to 0. So again, please take note that a function defined on some open interval containing point x sub 0 has a relative extremum at x sub 0 whenever f prime evaluated at x sub 0 is 0 or f prime is not differentiable at x sub 0. To determine whether a point is a maximum point or a minimum point, let us consider having f function which is said to be continuous at a critical point x sub 0. When we say we have a critical point, it means either the derivative f prime evaluated at x sub 0 is 0 or f prime evaluated at x sub 0 is not defined. Using the first derivative test, if f prime of x is positive on an open interval left of x sub 0 and is negative on the open interval right of x sub 0, then f is said to have relative maximum point at x sub 0. Okay? But if f prime of x is negative to the left of x sub 0 and positive to the right of x sub 0, then f has relative minimum at x sub 0. However, if f prime of x has the same sign to the left and to the right of x sub 0, then f does not have relative extremum at x sub 0. Simply stating that if we have a continuous function, then it will have a relative maximum occurring at a critical point whenever the derivative would change from positive to negative, or it will have a relative minimum whenever the change would be from negative to positive, going from left to right of the critical point. Another test for a relative maximum or minimum point is to use the concept of concavity. That if we have a maximum point, such as in this case, concavity around this point should be concave down, and if we have a minimum point, then concavity should be upward. This would lead us to the second derivative test, that suppose f is twice differentiable at a point x sub 0. Meaning, when we say twice differentiable, it means the first as well as the second derivative of the function are defined. So if f prime at x sub 0 is 0 and f double prime evaluated at x sub 0 is positive, then f has a relative minimum at x sub 0. This condition of f prime at x sub 0 equal to 0 will tell us that x sub 0 is a critical point, and if concavity is upward, then we have a minimum point. But if at the critical point the concavity is observed to be downward, as in this case, then what we have there is a maximum point. Now, if at the critical point the second derivative value is 0 then the test is inconclusive and that f may have a relative maximum or a relative minimum at x sub 0 or neither of this case. So the second derivative test is applicable only to stationary points where the second derivative exists. Okay, to recap what we have taken up in this lesson. First, that the first derivative f prime of x, when properly interpreted, will help us determine whether a function is increasing or decreasing at a given x value. That the second derivative value is associated with the concavity of the curve and will give us an idea of whether the curve is concave upward or concave downward. That the critical points of the function are observed at x values where the first derivative value or f prime of x is 0 or f prime of x is undefined, and that we can use either the first derivative test or the second derivative test to determine whether a critical point is maximum or minimum. Okay, so all of these principle, all of this concept we will be applying in the next lesson, and that will be on sketching curve.